and by using all this multiple combination, we started doing the multiple examples. Okay, now the remaining part is like on the calculation, like the mathematic function blocks, and then we'll be looking at mathematic as well as the comparators. So today we'll concentrate on mathematics and comparator. That's what we are going to do. And then once we understand the comparator and the mathematic blocks, we will try to write a logic for this applications. The application what you see here is a typical application in pharmaceutical industries. Pharmaceutical industries, generally what they have is like they have a multiple reactors, like what you see here. All of them are reactor, like one reactor. So reactor generally what they have is like they have the jacket for heating and cooling, and then they have the stirrer to stir the liquid, and then they will have the any other additional item like a pH control or like a manual hole like to dump material inside. So those setup will be there. So this is the reactor. One reactor contains one motor to stir, like it will stir the whole liquid inside, so that like you get the homogeneous output. And then you have the jacket for cooling. So the cooling temperature the steam will go inside to heat up the liquid. And then sometimes they will have the pH control, like they add the acid or base to achieve the expected pH, and then that's it. Like so with all this combination, they try to keep the product for a while. Like basically they mix multiple product. Like if you see all the pharma industries, the reaction is very simple. Like the process is very simple. Like taking a different material, like for example, this is a one reactor and this is another reactor. So these two material will be taken into one reactor in a different proportion. For example, like a 50 liter from here and 20 liter from here, and then once 20 liter from here, 50 liter from here, if they put together, then they will react by itself. Like well, like even the acid when you pour in your home, if you put the acid on the floor, it will try to take out the scales, right? Immediately react. The same way, when you put the two different materials together into the one, it will get reaction, and the reaction is actually your product actually. So, but sometimes that reaction requires a heating or cooling. See, some of the reactions are exothermic, some of them are endothermic. Like wherever the exothermic, when they react to material, they release a lot of heat. So you have to have a cooling mechanism. Otherwise, what will happen? The temperature will shoot up like anything, and it will damage the equipment. So they will have the cooling system. Like in some reaction, it is a endothermic. Like when you add this, the liquid will go very cool, luckily. But if it is going very cool, then product will damage. So for that case, what they do, they inject the steam, and the steam will heat the liquid. So like then once the two of the materials are reacting, what they do, they will try to maintain the pH. Like maybe it could be like a 4.5 pH. Then they will try to add the acid to it, because like as you know, anything pH less than 7 is acid, anything above 7 is base. So what they do, like when if they want to achieve the liquid the pH to the something around like a 4, then they start injecting the liquid, the acid inside actually. So they will inject acid by the dosing. They will send something, and then they will wait for a while, and then slowly they will inject and try to achieve what is their required pH. So once they achieve the pH, what will happen? Like two material inside the reactor will react, and then it will get you the final product. And the final product has to be there in a certain conditions, like a certain temperature, certain pH. Then once that is reacting for a while, maybe like a 1 hour, then obviously it will combine properly, and then combined product only it will be used as a medicine, like what you are using a medicine, like in a small tube or circle type, whatever the powder form, those all coming from this reacted value, like this reacted liquid comes out from the reactor and goes to the like a centrifuge. Like they have a centrifuge. What they do, what it does is like the liquid form. That this is a liquid form. The liquid form will be converted into solid form. Like they put the centrifuge. Centrifuge will run at maybe 1,500 RPM. In while it is running, when you are putting the liquid, like semi-liquid material, all the water content will go out. Only the powder stays there in the centrifuge, and then that is what the powder, they will take it out, and then they fill it with the small tubes, or like the acids they form in a different shapes, and then they finally close it with the aluminum sheet and sell it as a medicine. So this is whatever I explained to you. This is the whole process of any pharma industries. It's a basic process in a pharma industries. Like even if you go for anywhere interview, like you can spell out the process, whatever I said. This is what exactly they do. There are nothing else in pharma industries. Basically, pharma industries like mixing a two. It's not a two liquid. It can be like multiple liquid. I am giving you example. It can be two liquid, it can be three liquid, whatever, and then powder. So they'll mix it, and then they maintain at a certain pH, at a certain condition, like a temperature condition. Then once that condition is like maintained for more than certain time, then the liquid inside will react each other, and then it will get you the form, like a liquid form output, and that will be pumped out, and then it goes to the centrifuge. In a centrifuge, they convert the liquid form into the powder form, and then the powder will be taken, and then it's sealed in the aluminum sheet with a different shape, and that's how the medicine comes as our utilization, right? Right. This example we have taken now for the our further demonstration of the calculation as well as the mathematic function block, and the and our the comparator blocks. So we have two functions, the comparator and the mathematic function blocks. With those two, we should be able to achieve the complete logic what is required. Obviously, you need the AND gate, OR gate, set result, flip flop. Those always be used, but the calculation, it also takes some part, because without AND gate, OR gate, or set result, flip flop, timer, counter, you cannot do a logic, because logic, it's very hard to achieve any logic. Those are very basic. As I told you, like almost like it covers like a 70 to 80% covers the complete logic implementation in any PLC. So if you are, so far whatever you described, those function blocks, if you know, that means 70% of logic you can understand in the industrial environment, if you are clear, right? So now this one will slightly like maybe 5% or 5 to 10% where I have a weightage, but still it just got something like in a pharma industries or chemical industries, these calculations work out to the best possible, right? Whereas in the other industries like the engineering industries or some other industries, normally it won't be used. But yeah, we need to understand how exactly it is. Okay, now we're going for the let us try to understand how this the mathematic function block works and how the comparator works. That's what we are going to see it now. Right. If you see, if you go down here, like the under the analog, you have the analog. Once you say the calculation generally works with analog, or maybe like in a counter, even timer also it can work. So let us work out, let us find out like the multiple the utilization, how exactly it can be used in the industrial environment. So I'm trying to pick up the analog mathematic function block, right? Now let us understand how this mathematic function block works. So if you understand very correctly, then when we are building the application, it will be very much useful, right? So now in this block, you can see there is a first pin is there. This pin is enable. Enable means like if you want this calculation block has to function, if it needs to execute some task, then this enable should be given as a high. Otherwise, it won't execute. Maybe the calculation it will try to perform. You would have given some calculation formula, but that formula, though the formula is inside the block, it won't execute. It will execute only when you are giving high. Enable should be given. Like for example, high can be like see, like if you go to the top digital, there is a status high is there. That means this block always give high. Always it gives a 1. So wherever you want to enable it, you can use this block to enable it. So this will always give 1. So as long as the enable is high, this function block start executing the calculation implemented inside, right? Right. Let us see what is inside. So when you double click on this block, right, this is what you see inside. So you can see here V1 is there. After V1, we have a operator. This operator is like if you select operator, you have multiple operator plus, minus, multiplication, and division, right? So you can have the any formula you can apply, right? And then you have the priority also, like a high, medium, low priorities there. That means like if you say high priority, even you can add, for example, let us say as you aware standard, like if you find any equation, the first execution is going to be multiplication and division. Sorry, I think bracket. The bracket is the first execution. After the bracket, multiplication and division. After multiplication, division, plus and minus. So this is the sequence, like order of sequence in any of the calculation. So that you can determine by selecting even you can force it. You can force what you want actually. You can say low priority, high priority, medium priority, you can say. So that way what will happen, if I say, if I have something like if I put a high priority and if I put a medium priority, that means my first calculation will do this. Like this execution will be done as a first, and then it will do the next execution, medium priority, and then finally it does the low priority. Like you can see, medium, high, and then we have the low. So we have a 3 priority we have. So based on the priority what you choose, you can determine which calculation to be performed at first stage, right? Also possible. Right. So this is saying like a V1, some values there, and add with V2, and then that can be added with V3, and then you can add with V4. So this is a simple calculation. Just we want to see how exactly is it performing, just to find out. It's more or less like a calculator, how it is doing. So I will say 52 plus 3, so 55 supposed to be answer. So I will say okay. So now I want to simulate this and see whether it's giving correctly or not, right? So you can see here bottom, you can see 55 has come, but I want to demonstrate to you what if the input is not high, what will happen. So for to simulate that, I can do what I can do is I can do this. There's a lot of way to test it, but just I'm putting one way to get you some idea. Like even if you can use the digital input just to demonstrate. If it is not high, it won't execute. That's what I will see. Like if you look at the block, see underneath the block, you can see the value here, right? So now you are seeing a 0, slightly to overlap with the okay. We can I think we can disable it. We can disable the comment. Right. So to disable the command, you can go double click on it, and you go to the top one, show parameters. You can remove the tick mark and say apply and OK, it will remove that the parameter display will go off. Right. Now, if you look at this, right now, there is a calculation inside. Like if I look at here, I'm opening this, there is a calculation. The calculation is like a 52 plus 3, it has to add. But if I look at the bottom, I am getting a 0 only because it's not executing. The reason is like the input is not high. That's why it is not executing. So now we make it on. So now it's able to execute because it is enabled actually. So you have to be very careful, like when you're building the mathematic function. So make sure that the inputs are the enable input is always set to high. It can be used a conditional calculation also. Like it is not necessary a calculation has to be performed all the time. Maybe like you can make your logic whenever the calculation to function. That time you can activate, and then it will give you a result, and then after that you can switch it off. Like there's a multiple demands and requirements are there. You can use it based on what is the requirement. Right. So whatever so far we have seen is like we have seen a simple calculation. Like as long as the input is high, it execute the calculation inside the block. Now this is like a 52 and 3 is a simple. I am entering a value, but our demand, our requirement may be different. Maybe like two machines are producing some product, right? Maybe like the first line may be producing a like car steering or whatever, and maybe the second line may be producing a car tire, the wheel, like whatever. So now our requirement, we want, let us say we want to add that dynamic production in the plant, right? That is our that could be our possible application, right? So how do we achieve that? So this is a simple calculation. Like I'm entering a value like 52 plus 53, 52 plus 3 is a 55, which is a normal calculator function. But how do we get that production into this block, and then how we calculate, how do we get the result? That could be this our requirement, our example. Like let us say we have a I'll go for configuration mode. Say I have the two production line, right? Say I assume that this is a like a car wheel, actually, right? So let's say car wheel machine producing something like product. Every wheel, like in a car, every time like it produces one wheel, it gives a one pulse. Like as remember, like yesterday we have seen a bottle sensing. The same way, when the wheel moves through the production line, there will be a sensor. Sensor will sense the wheel moving. Once the wheel move out, it goes to 0. So 1 0 1 0 1 0 comes, right? That's the same philosophy. Once you know one philosophy, the same philosophy can be applied for everywhere, right? So then let us say I have the like a steering, like right. This is a steering, car steering, like a manufacturing. So as and when the car steering is produced, we want to count it. That's basically what we want to know. We wanted to our intention is to find out how many total products produced in the company. Like it can be wheel, it can be steering, it can be anything. Just we want to accumulate, and we want to display somewhere what is the actual production is produced so far, right? That could be the possible our the logic requirement. So in that case, what we do, like as you all aware, we can put the counter. So this counter is normal. Like I'm clicking on the counter. We'll put a counter. The counter will go to the count, right? And then again, this is a wheel counting. So how many wheels are produced in the company? And then we have another like a steering. Like let us try to count the steering, right? I connected the number of steering production. So you have to be very careful when you're connecting. You have to connect on the count, CNT, not the reset. Okay, that's what we have to be little careful. Reset if you put, then it won't, it will be resetting always. Like make sure you are connecting on the count where you have the up direction, like the up arrow is there, right? So now we understood these two are going to count what is the production. Now we wanted to know how this product can be totally we want to make a accumulator. We want to find out like what is the total production. So what I do is like as we discussed, I will set this always high, the enable, because I want to execute the task always. I want to enable always. It's supposed to count, keep counting the total production. So and here now we wanted to say we wanted to count the two counters, like what if you look at this is the value, the name of the block is B002 M2, B003 and M3. That's what it says, right? So this is the block name. So now what we can do, you can go here nearby V1. The V1 can be either a direct value or it can be reference. So the reference, when you click on this reference, you can see it will pop up all the blocks inside actually. See, so if you see here, in so far what we have is like a like a B002 M2 and B003 M3. We have a two counter block we have. So it displayed the counter block. So I wanted to take up the first value, add with the second value. Like in this location we have a 3 is a static value. So I want to make a dynamic. So here it is a M3. Right. So basically what I'm going to do, all the time I take the counter value of B002 M2, which is a wheel number of wheel production, and then we have a B003 M3, which is a steering production, like how many steering is produced. So these two will be added, and I will get the result of how much total production. That's what our logic recommend. That's what we implemented also. Right? Let us check on how this is working. Right? So I'm going for this simulation. Right. So now let us see like the count. If I look at the count, the I003 is on, and then there is a count is 1. That means there is a one steering got produced already, and whereas the wheel, it is a count is 0 because there is no production so far. So 1 plus 0 is 1. So you can see the calculation block top. The 1 is the actual result again. So let me try to produce the wheel again. So now the wheel is produced. You can see 1 is there, and 1 plus 1 2, because the calculation block is functioning. So as long as like if I am producing, like I am let us say I made a multiple product now. So I made a 5 wheels production, and here we have a steering is a three steering we produced. So 5 plus 3 is 8, right? So it's a kind of a, so this is how the calculation block works. Like what we have made is like a simple calculation block. Like we were adding 2 production line. So it can be like it can be multiplication, it can be division, it can be any formula. Any formula can be implemented, and you take a result of it, and that result can be used somewhere to make up your logic or whatever, right? Right. Let us say, for example, just for a sake of understanding this requirement, once you produced once you produced a 100 number of total production, you can close off the day. That means like there's no more production, you can stop all the machine. If that is a requirement, what we do, like we take the total production here, and then we can compare it, and then by comparing we can the decision we can make. The comparator output can go to the plant stop or machine stop or whatever, we can stop it. So the basic calculation is very simple. Like the mathematic block is inside, all we have plus minus and everything we have, and also you have a function called reference. So this reference will allow you to connect to any of the parameter which is an analog value. Whatever the analog value available, it will give you the provision. So then you can choose whatever the analog value, you can add it, and then you can use that for total calculation, and then you can achieve your logic, right? Hope it should be clear. It is not a big complex one. It's a very simple one, but still, if something is not clear, you can always ask me. So maybe I can stop for next 1 minute. So make sure you understand correctly. And if something is not clear, you can always ask me. So I'm going to stop 1 minute for you to give a feedback. So I presume all of you understand the calculation block implementation. So I'm happy that you all of you understood correctly. Um, right. So now let us go to the next one. It's what we have seen is the arithmetic function. See the other function we can always implement, like right now we have tested only for addition. So if you want to do a multiplication, you can do a multiplication, you can do subtraction, everything is possible, like it is just by selection actually, right? It's not a big thing like such. It's because you're going to select the operator and it is going to do the job actually. So once you see one example, I'm sure when you are doing the process example, and yes, obviously you can use it and you can test it, right? Now we are switching into the comparator. So let us see how the comparator can work. Right. So the comparator again. See, the compare, always you compare not the discrete. You always compare the analog value. So so the comparator always be inside the analog only. So you can see here. Uh, the first block, what you see here is an analog comparator, right? So under the analog, you have an analog comparator. So I'm taking the analog comparator and just let us go through all the various possible, like the parameters, how exactly this executes, right? So if I see the comparator, you can see there is a two legs are there, AX, and then you can say AY, right? When you connect any value, like if you want to compare a value with some value, then the value which needs to be compared actually, that you can connect in the first leg, and the next one you need to connect with the another value against which you want to test, you can connect there actually, right? So always it checks when this value is greater than or less than or whatever, the equal or whatever, all will be happen. So always it takes the first value as a reference. If this value is greater than this, less than AY, that's what the comparison takes place, and then based on that the result will come. The result, for example, let us say you say I want to check when both are equal, I want a on. Yes, possible, you can do it. The other way is like hey, I want to check when this value is greater than this. Yes, you can. When it is greater than that, you get the output based on, all can be achieved based on how you are configuring this block. See, only one block, but whereas based on how you are configuring, it works that way, right? So let us test it. To test it, I'm going to take a like a analog input. So you can use you can use the counter also, but just for example, I wanted to get you the understanding. So assume that we have a two analog input, right? Two analog. One can be like a level in a tank, right? Okay, one can be level in a tank. Let us say 0 to 1000 liter we have. and another one is having a 0 to 1000 liter. So we have a 2 tanks available. So our requirement is like a whenever this the top tank level is more than the bottom tank, then I want to do some action. Yes, it is very much possible. This is a compare directly. This is something we want to compare the analog, this analog input to be compared with this analog input, and to find out this analog value is greater than this value. That's what we need to find out. That's what the block does. The block compares the AI001 and AI002, and then if it is AI001 is greater than this, by what value we can define, like maybe like a more than 1, more than 3, more than 5, more than 100. Yes, we can define inside the block. Once that is achieved, the output will become on, and that can be used anywhere in the function. So I'm going to connect it. I have connected the analog input 1 and connected the analog input 2, right? So the two inputs are connected to the comparator. Now we wanted to see what is inside the block. Right. So this is the what is inside block. You can say like you can define what is the actual the value, or how much value you are going to compare or whatever, but your interest is on threshold. So this is what, like, where you have the threshold, like if my requirement is like when both are same, I want output, then I will leave as it is as a 0. Like for example, like I wanted to check when my AI1 is more than 500 from AI2, then I want to make it on. So like this was on. On means like we are saying when to switch it on the output. So we are saying now when you compare AI1 and AI2, and if AI1 is 500 more than AI002, if AI1 is 500 more than 2, then the output will become on. That's what the meaning of it. So we'll try to visualize, and then you get the idea, better idea. What is my explanation? Right. If you look at there, like I'm switched on to simulation mode, the output of the comparator is off, right? Because like right now both of them are 0. So now I am trying to simulate this. When you click on the AI, it gives you the simulation. Because I'm in the simulation mode, it gives you the simulation function so that you can vary the value. So I'm going to simulate the value. So I'm increasing the value. Right now I've given a 17, right? 17. Now if you look at the comparator bottom, this is also showing 17, because this is always it will subtract the AX minus AY. That is the result it will display. For example, let me take the right now you are seeing 17, because the AI001 is 17 and AI2 is 0. 17 minus 0, 17. That's what it shows. Okay, and then let us say I have the 8 now. So since I have 8, the comparator bottom, if you look at it, becomes 9, because 17 minus 8 is 9. So this value only being used, whatever the result comes, this value will be used to compare inside. Whatever the value you put on the on, it will compare, and then the result will come. So now as per our logic, if the value of AI1 is how much, like a 500 more actually. If my AI value is 500 more than this, then the output will come. So either I can vary the value like this, or there is a possibility like if the bottom, if you see there is an analog IO is there you can punch the value, direct value. Like I can directly put a value 507, right? 507. If you see here, I put up 507 on analog input, right? This is analog input. Like in a tank A, I assume that there is a 507 liter of water is inside. That's what I'm trying to simulate. And the tank B is a tank B level measurement. Is the analog input. Like the analog input is the transmitters which transmit the tank level in terms of 4 to 20 milliamps. 4 milliamps corresponds to 0 liter, and 20 milliamps corresponds to 1000 liter. Right? That's what the logic we. That's what the understanding what we learned very initial, very first class. Like we learned what is analog input. Analog input is the measurement of a field in an analog form, like like if you have a tank level 0 to 100% or 0 to 1000 liter. So it needs to be, it's not like a tank level full or tank level 0. It is a kind of like what is the level inside, maybe 52 liter, 75 liter, 100 liter. So all it's a analog value, but analog value you cannot use the digital input because digital input make 1 and 0, so you cannot understand. So we have to use a analog input, and the analog input normally will give output of 4 to 20 milliamps. 4 milliamps corresponds to 0, and 20 milliamps corresponds to 1000. That is what this two tank measurement, right? AI1 and AI2. So this is a tank 1 level measurement, which is 0 to 1000 liter. Tank 2 level 0 to 1000, right? So now the first tank is a 507 liter. The second tank is 8 liter. So when I subtract this 507 minus 8, 499 liter is the top one is 499 liter more than the second tank. That's what the meaning, right? So I wanted to enter like a 508, right? So now I entered a 508. So now what it's saying, the top tank is 500 liter more than this. So if I increase one more, right? So now it's gone more than 500. So now the output of the comparator has become on. So because like we put inside 500, so when the tank 1 value is more than 500 more than tank 2, then we want to switch on something. If you would like to do that option, you can configure this way, and then this will make it on. So now that on can be used anywhere in the logic. You can wire it to the motor, or you can wire it to the valve. Whatever the output you want, you can switch it on, switch it off, whatever you want, you do it. So this is the comparator, how exactly you can compare two value, and then accordingly you can set the output, right? Like for example, like if you want to compare, like, hey, I wanted to compare this one against this. Yes, you can connect this tank on top and this one bottom. So you can do whatever the way you want. It's the basic idea how this can be achieved. Now this has got another function also. This function block. If you see this one, like there is a off also given when this supposed to be going off. Like for example, there can be some application where for some value you want to make it on, for some value you want to make it off. Yes, you can do that also. Like for example, I want to make at 500 I want to make it on, and maybe like 600 I wanted to make it off, right? This is my requirement. So then what will happen, like at 500 right now it is on. If my analog value is more than 600, like I will say 608, now it's gone off. Like I will go slightly, I will reduce it. See, now 599, for 599 it is on, whereas if I go for a 600, it's going off. So you can switch it on and off based on what value. So 500 you can say switch it on, and 600 you want to switch it off. So both are possible, right? So the comparator can be used in any comparator comparing of any values, and you can do it, and you can get the result, and you can based on the result, that result can be used in any logic. Hope it should be clear. And I maybe like I can stop for 1 minute from now. In case if something's not clear, you can ask me. So from now 1 minute for your feedback. Okay, so I presume since there is no question, so it is a clear. So everyone understood correctly. That's what I presume. So now I'm going for the process example. Let us go to the process example and try to find out how exactly this can be implemented. And so once we implement this, the more or less like you have a better clarity for working with any industries. Maybe when you go for industries, the number of logic may be more but similar logic in more in number. That's it. So, but this is like a one logic. If you understand one logic, and the remaining all can be a copy paste and then modify the addresses. That's it, right? Okay. So now the logic is like a you let us say we have a two buttons. So let us take the let's take the two buttons. Just a, right. So we have a two buttons. One is start process, and then the address can be uh, 002 used 8003 I can use. I004. So we have a start I003, we have a stop I004. Now let us try to understand this logic, and then we will try to build the logic for it, and then we will see how exactly we proceed further. When I push and release the start, basically like we have to start the whole process, right? Whole process to be started actually. Anytime when I stop it, you want to stop the whole process, right? So the same logic like what we built last day, the production, the same way when you start like we yesterday we produced we worked on this. Like when you start, the whole sequence has to start, and then when you stop, the whole sequence has to stop. That's what we have learned, and that's what we made the program. That's what we tested also. So the same philosophy, this is the same philosophy. Like every plant, everywhere, wherever you go, people used to use the same philosophy. Nothing is a major difference. So the moment when you push and release the start, yes, the whole sequence can start. And anytime when I wanted to stop it, you can stop it. Right. What's supposed to be the sequence? Like when I say first start, once I push a start, then we wanted to open this wall first, actually, right? Okay, let us say the first wall, this wall we will say. So when I click the start, we want to open the wall, this wall first, and this wall has to look at this value once the liquid from this tank, like I assume that 500 liter, once the 500 liter from this tank is passed to this tank, then it has to go close. Okay, so once I start this logic, once I start the process, the valve has to go open, and once it goes open, it should remain open until the tank level reduces from 1000 to 500, because once it opens, the liquid will start flowing from this direction and then trying to pour inside again, right? And as and when the liquid start going out, the level in this tank will going to go low, maybe from the 1000 liter, maybe 980, 950, 900, 850, 800. So slowly will come down. Once it touches the 500, we want to stop this valve, close this valve, because like we don't require anything else further actually, right? Now, once this is closed, right? Once this is closed, we want to open this valve, right? So this valve can open, and once this is opened, the liquid in this tank is going to fall into the tank slowly, right? So it will be like a once it is open 950, 900, 850, 800 slowly. Once it goes like 499, which is slightly less than 500, this valve has to close. So now basically what we did is like we have added a 500 from here and 500 from here. So once we pass a 500 from here, 500 from here, then we want to start this agitator. This agitator, like, because as we said, because basically what we are doing is we are writing a real logic for a company, like for a chemical process, like where a pharma industries. For the pharma industries, we are trying to write a logic. So this is a real logic what is running inside the plant, right? So once you once the level in a tank 1 and tank 2 is less than 500, I mean like a 50% is transferred to the system, then the agitator can start, because the function of the agitator is like, as we discussed, this is just to mix the liquid very well, right? Because whatever the two liquids are inside, the two liquid has to mix very well, and so that like the reaction takes place very well and the quality will be better. That is the ultimate motive of a agitator, nothing else. Because if you don't agitate, what will happen, like only a portion of the material will come in contact, not every material, like maybe like a few material not at all mixed with others. So then what will happen, the product quality will go low. So for to achieve a product quality, they start the agitator and they run for some predefined time. Okay, now once you start the agitator, maybe like a agitator can run for maybe like a 10 seconds. Okay, generally in a company it run for 2 to 3 hours to get a reactor, because in a one shift normally they used to take a minimum of two product, they used to take it 2 times. It's a general concept, but sometimes like it can be one product also, because sometimes it makes a longer process. Sometimes it can be three batches also, but it won't be more than 3, it won't be less than 1, right? So now once you start agitating, the reaction takes place, and after a 10 seconds, just for our testing, after 10 seconds we need to switch off this, start the motor and stop this agitator, because we need to stop the agitator, because the reaction is stopped actually, reaction is finished. And then you still, we have multiple controls are there, like pH control and everything is there, but we don't want to complicate too much, because if we may complicate too much, then it's a problem, then we cannot understand properly. So just not to complicate, we are trying to make sure like we understand correctly. So now once the timer is finished, like 10-second timer is finished, you stop this, start the motor, so motor can take the output from here and then it send it out, right? So this is the logic. Basically what we are trying to do is like we are going to use the comparator, right? We are going to compare the how much is gone, and maybe like you can display here like maybe like, if it is a SCADA system, like what normally they do, they used to display nearby the system like how much material gone inside, like they used to display here actually. So maybe like we can display also, like for just for a display purpose, we can put something like here, tank level, right? So tank level, so it can be in a value, in a level format, like in a liter format, #.5 liter. Generally in a SCADA system, like normally they used to display how much is running inside. So this also we can achieve it with our program. So basically what we are doing is like let me repeat the task quickly. And okay, while the process is going, anytime if I stop, all has to go off. And then when you start again, and then again, same process can start. That's what we want to do it. Just I want to repeat you the logic requirement. So initially, if I push it, when I push it, you open this valve first, and this valve can open. Once it is open, we can simulate this level slowly, like a, because see, like once you open, water will go down in a real scenario, in a real plant, the level will come down. Whereas in your logic, when you open it, level won't come. You have to simulate basically, because like it's a simulation. It is not an actual plant actually. Really, the level comes down. Right. So once you open this, I can simulate this level from 1000 to 499. Once 499 comes, this needs to close, and then this has to open. And once this is open, this liquid starts flowing through the valve, and slowly it goes, and then this also we need to simulate from 1000 to 499. Once we simulate 499, this has to close, and then agitator had to start. And once the agitator is running, we set a timer also, like maybe 10-second timer. So it will mix the liquid, internal liquid, for 10 seconds, and then after 10 seconds it stops. And then while stopping on this device, you can start the motor, because like we need to pump out the liquid from here and send it out, right? So you can start it, and then the whatever the liquid inside, you can display it, right? Maybe like after this, we have a further logic, like when to stop the motor. Maybe stop motor needs to stop after maybe 10 seconds or whatever, something like, okay, we have multiple logic to do it, but okay, let us limit the logic up to this. Anytime when I'm stopping the process, it has to stop. So this is the whole logic which needs to be done, right? I hope the logic requirements are supposed to be clear. So I can stop for a 1 minute to see, in case if you do not understand the logic very well, what is the logic requirement, you can ask me. I can repeat for you so to understand. Otherwise, like, we can proceed. So wait for a 1 minute from now. Right. So I presume that the logic explanation is correct. So we'll proceed accordingly. Like, let us try to make the logic now and try to simulate how exactly we can achieve it. Right. I'm going offline to delete everything. So I'm going offline. Hit delete. Right. So the first logic is like if you look at this process, we said clearly, like when you start the green color button, we need to start the whole process. Anytime when I push it, it has to stop. So let us do the first this into the as a first step. Let us do it. Right. I'm going to do it now. So now my this I001 is a start. I002 is a stop. So we have a start and stop. Right. So we want to, let us use the set reset flip flop. Right. So what we do is like whenever you set it, like whenever you start it, whenever you push the start, the whole process can start. Whenever I stop it, the whole process can stop. So now we achieved our initial statement that when you push the green color button, the process needs to start. When you push the red color button, the process needs to stop. That initial statement we achieved now. Right. Now, once you start it, we want to open this valve. Right. So let us do that. So now, once it become on, we wanted to open a valve. So for a valve, we can say we can output Q. This is a Q001. You can see the PowerPoint like the valve 1 address is Q001. So we can say valve 1. So it's a valve 1. We have a valve 1. So this valve 1, like as you said, like whenever it is, whenever we trigger it, we wanted to make it on. Right. So this logic is like first statement is okay. When I push it, it starts. When I stop it, it stops. So that's correct. But this open valve has to go close. The open valve has to go close when the 500 liter of the liquid is transferred. Okay. Right. Let us do that. Okay, we're bringing here. Let us say this is my tank level 1. My tank level 1 address, like my start and stop. Let us check what is the address, start stop level address, the start stop process address, I003 and 4. 3 and 4 is a start and stop. So let us match it. So this can go here. This is a 3. This is 4. Okay, 4 won't come. So that we make this is a I1, like my tank level 1, and this is my I4. Right. So I3 is start, I4 is stop. This I'm trying to match with the document. I003 is my start, I004 is my stop. So I made I003 start, I004 is stop. And the tank level 1, what is the address? So let us see tank level 1 address. The tank level 1 address is I001. See, like in the same channel, you can connect an analog input and analog output, because this PLC is a configurable PLC. When you connect a digital input, it assumes the 1 0, and then when you connect analog, it assumes the analog input. In some PLC, you cannot use it both. Digital input, you need kind of digital input. Analog input, you have to buy a separate card, not a same card. So it's a PLC to PLC, it differs. So only what we need is like now, okay, if a same channel is not accepting, you will give another channel. That's it. So that's what the difference. In a the real scenario, that's what happened. So now I entered the address as a I001 is my level 1, my level 1. Tank level 1, right? A tank level, tank 1 level, right? So this one, what we said is like if this value, when this valve is open, if the value goes less than 500, we want to close the close this valve, right? So what we need to do, we need to have a comparator. Like let's take comparator. So we have a comparator. Okay, if this value why right inside one simulation, let us or it's going to switch. Okay, let's do this. Because the inputs are, it's a switch. Let me check this. Mhm. Sorry. Okay, I am doing a mistake. I what I tried is like I am see what I was trying to do. I am taking the digital input. I'm trying to connect to the analog input. That's why it's not connecting. See, like see, I'm doing a mistake. Like basically, what I picked up is under a digital there is a input is there. I picked up and I am trying to connect the digital input, the digital input to the analog comparator, and it is not connecting. So see the block itself, like the program itself, it is trying to understand my problem, and it is not doing it again. It is avoiding. So it's a correct actually, because technically correct. So what I supposed to do, I should take analog input because it's a tank level, right? So the system also helping me to understand why it's not connecting. Now, if I kind it will connect actually, right? So you can see the kind because that's a small mistake. See, when we do a mistake, the programs are made to some extent. You can correct by yourself. It's not like a you can type whatever you wish, and when you execute, it comes wrong or whatever. No, very initial itself, like when you're trying to do the program, if anything goes wrong, it will pick up and it will get you the the location of error again, right? So now I have taken the tank level 1. So let me say tank level 1. So level 1. So it's my tank level 1. Then um, this level is if I go here, um, this level is this level we want to compare. You can say you can put a you can put analog math block. You can put, right. So you can put analog math block, and you can see, because I need to feed a value here to compare it actually. So I want to kind of comparator the analog value, and I want to set a 500, right? So basically, like I need to feed a value of 500. That's what my intention. But I need an option like instead of taking other block, I'm taking this, right? And this one, as we said actually, this can execute only when input is enabled. So for that reason, I'm going to make it a status high. So I'm going to make it high, right? See, you should understand the reason for it. Like the reason for connecting this into this is I wanted to connect a 500 to the channel, because my requirement is like if my value goes less than this, I wanted to switch it on. That's what my requirement. So that is why like I want this 500 value to be feed in. So now what I'm doing, I'm making a high, because this function block has to execute, and inside I am putting a static 500 value. 500 plus 0 is going to give me 0, right? So 0. So now if it is 1000 minus 500 is going to be 500. So when this comes 500, I can make it 0. So if the value is less than 0, I can make it on. Like I will go here, I will leave as it is. So now my next logic is like when the tank level is less than 500, I wanted to stop this. How do I stop this? Now I have given a direct wire. So how do I stop it? I cannot stop it, right? So what do you do is like you can delete it, right? So then you can bring a one AND gate here again, because the AND gate is like the reason why I bring an AND gate is like I'll tell you why I bring an AND gate. This start logic can start this open this valve, provided if my tank level on the first tank is not less than 500. That's the meaning, right? So if it's 1,000, that means the water did not, the liquid did not come to the main reactor. So if it is less than 500, that means that liquid from the first tank transferred to the main tank. So that's why I say, when I'm starting, you open this valve provided if my first tank level is above 500. That's what the logic I made actually. Okay. Hope it should be clear, because if we don't understand, then maybe it's hard to proceed further. So whenever I am pushing a start, I am latching it. When I want to stop, again I will unlatch. So once this becomes zero, all will zero. So when I'm making a latch, what I said is like a very initially, once I push a start, we need to open this valve, right? So that's what I have done. I open this valve. However, in between this, I put an under gate because I'm trying to make sure. Remember, like I need to, when the tank level is high, let's say tank level is less than 500, I want to stop this. So I want to bring a two condition. One is initially I want to start. That time the tank level is more than 500, but when the tank level comes less than 500, I want to stop it. That's why I brought a AND gate. Hope should be clear. In case if it's not clear, you can always ask me. Maybe like I can give you one more minute to make sure so far you understand or not. 1 minute start from now. Right. So it looks like everyone understand correctly so far. So let us go ahead further. Right. No. So now once I start, I'm going to open the valve one, and while the valve is open, slowly the liquid will come down, and this comparator is going to monitor this tank level. And if the tank level goes less than 500, so 500 minus this 500 zero, so immediately it become on, and when it becomes on, then what I do, like we stop it actually, right? So now we understood so far, like once that is this comes, we are stopping it actually. Okay, now we need to start the next valve actually, right? So now how do we do the, and we should not be opening before this. That's what the logic we said actually, right? So now here you have to think slightly like more powerful. Otherwise, like you cannot execute. So when you start it, when you start it, see, the second wall can go open only when the your start is enabled. Like see, you given a main start, right? The green color you pushed, but in case if you push the red color button, it will go off. So that is a must in AND gate. One of the conditions. That means, as you know, AND gate is all one should be there in order to proceed further, right? So one of the condition is it should have been started, right? And it should have been started, and it should have been closed. So this should have been closed means like we need to make a NOT gate, because like this can go close only when the less than 500. After that, we want to open the valve. So I want to put a NOT gate here. See, this is my I said some logic, but this is my initial implementation. But there can be slightly the something can go wrong also, but also always we can fix it after seeing the result, right? So my initial thing is like when the valve is closed, and if the system is started, then I wanted to open this valve, right? Now we have another condition. This valve has to go close. Like I will take the valve. Okay, let me kind of valve number 2 now. This is the Q002. I think so. Let us check. Yeah, Q002 is the valve number. Right, Q002. Now the requirement is like this valve has to go open after this valve close, the first valve close, and the system is running. Also, if the tank level goes less than 500, tank 2 level goes less than 500, we want to stop it again, right? That logic also should come. So I will copy the top one. This is similar logic for the bottom also. Right. This is A2 because like let me check what is the address. Yeah, I002 is my address for the tank level 2. So this is a tank 2. It's a level. It's a lot level 1. It's a level 2. When the level 2 goes less than 500, we wanted to stop it. So that's what we wanted to try. We wanted to stop it. So now we understood like we have stopped the 2 valves. So that means like we have taken a 500 liter from one tank, 500 liter from other tank. We have taken a 2 valve. Now after you took this 500, we want to start the agitator. That's what we said, right? Okay. So now logic could be this way, like again we want to make a AND gate. So what's supposed to happen is when this valve is closed, and right, because 500 liter is already taken. So you have taken the 500 initial 500 liters. Let me do the wiring properly. Okay, we can move it here so that it will be clear, more clear. Right. So when this valve is closed, that means you have taken one more 500 liter. And if the system is really started, then I want to start the agitator. What is the address of agitator? Agitator address is like a Q003. So we will start the agitator. Right. So the agitator is running now. Right. Now the agitator, as we said, the agitator can run for 10 seconds and then we want to stop it. So then what we do, we take a on delay timer, or it is simple word, like you can let us try this. There's a multiple way we can do this. It's a 10-second timer. Like I will put a 10 second. After 10 seconds, we need to stop this. How do I stop it actually? Because the AND gate is there, and then this one is there already connected. Somehow I need to stop it. How do I stop it? So that means I need to bring some mechanism inside here. Starting is okay, but stopping also I require actually. So now what we can do is, right. So whenever this AND gate comes, we can say we can use another mechanism. Okay, I want to tell you one small another function block, the functionality of this function block, because I want to use it, but I am telling you like the functionality. See, this one is called a pulse relay, right? This is a pulse relay. What does mean? What is the use of pulse relay? Okay, we are not going to. Okay, we will the previous one, whatever we so far developed, you keep as it is. Just explain this and then understand this, and then we go for the logic. This is a pulse relay. Pulse relay means when you give a input. For example, let us say I'll take a one input just for testing purpose. When you give a input, how much second you need output, that's what you can define. Let us say I want a 3-second output, 3-second pulse output. You can visualize what is the meaning of it, right? So right now I made a off, output is off. So this relay called a pulse relay, pulse output relay, like it gives a pulse output. Meaning if I make it on, you can see, carefully watch the timer how it works on. When I make it on, the output is on. This on will be there for only 3 seconds. After it goes off, though the input is on. So every time when the input goes off and on, 3-second pulse output will come, right? So for example, let us go off. Now it is off. If I make it on, 3 seconds it will be on, and then it goes off. So it's called a pulse output relay, right? Pulse output relay. So just I wanted to make sure like you understand the pulse output relay. Maybe like I can hold for a 1 second just to make sure. If you have any question, you can ask me on the pulse output relay. 1 minute start from now. Right. So I presume looks like everyone understand the pulse relay very well, right? So I'm going to use that pulse relay in the logic. So I'm going to go for a offline simulation. So I'm going to remove this. Sorry, I want to remove this. I want to use here actually like in my here I want to use it, because like whenever the input comes, I want to use one pulse relay. You can visualize, like see later, like when you're executing, you can see the reason for it, right? So now then we wanted to set the output, like for example a normal methodology like a set reset flip flop. I can make a set reset flip flop. I set it and then I'll bring it here. Once my timer is done, then I can reset it. Right? These are all normal logic what we built last time. Like once the input to come and then it will become on and the timer starts after 10 seconds. Okay, 10 seconds. 10 second, after 10 seconds, it gives a pulse. That pulse will come here and then it stops the queue. Right? So let me switch. Sorry. Let me remove the comments so that it will be clear. It's too many. I'll remove this comment. This parameters. So it looks a little clean actually. So I will say 1 second is okay to me. Right. So maybe like I will align slightly with a less space. To make a clear understanding, this way. So now it should be a little clear. Though there is no clumsy, so it should be okay. Right. So now, once this after the completion of this, we wanted to start the bottom pump, right? So this is agitator. So I will say agitator. This is agitator, and just to make sure the number we have given, agitator is Q003. Yeah, 3. Right. So then we have the after the 10-second, we wanted to start the motor, right? We can say we can put the same set reset. Here we are starting that, but for the outlet pump after 10-second, maybe we can start. You can say too many blocks, so I'm trying to make the space better. Right. Right. So once the timer is done, means like a 10-second is finished, you stop this motor, whereas I start the other motor, like the pump outlet motor, the tank outlet motor. I'm going to start this. That's it. So, but we did not say when to stop it. Maybe maybe we can say like this can be stopped for just for because we need to complete the logic. Whenever you stop the main one, let us stop the bottom motor, because we did not say logic, but still for a completion we make it. Right. So now let us review the logic. See, like this is a one stretch logic. If anything logic, when you build it, it won't be first time, it won't be correct, because you have to 1 or 2 times you will delete and then do something and then you fix it. So that's what now I'm going to do the same thing. Like I'm going to review my logic and make sure did I write correct logic or not. If something is not correct, I will try to fix it. Right. When I say start, push start, right, this is my start logic. So when I am pushing start, I wanted to start, like once it start. So you can see, let me organize slightly better. Yeah, so just it's well readable now. Right. Once I start this, the start output will come. So this is going to go this line, and then AND gate is there. Here, if it needs to pass the AND gate, this also should be 1. But initially, will it be 1 or 0? That's what we need to find out actually. Otherwise, it won't work. So let me see. This is the tank level. 1000 will be there. 1000 minus 500. It's a 500. So the so this can go on. So the tank level is 1000. Let me check. We will go for simulation and check it up. What it is giving. So right now the bottom is a 500. It's giving a minus 500. If I simulate 1000, let us say 1000 is on. So it is there actually. So slowly, when it comes less than 500, it's supposed to go off. Just I want to test it actually, make sure my logic is, yeah, it's going off. So it's correct actually. I'm going to go for offline. Just I want to simulate, like, okay, the first time when you start this button, the green color button, you are going to set it. Set 1 will come here, and then in this leg also 1 will be there, because tank is full. The first tank is a 1000 liter is there. Like in this, once you open this valve, right? When I'm pushing this, I'm opening this valve first. By that time, when you're opening, this tank will have a 1000 liter. So when it's 1000 liter, we don't want to stop it actually. So let the valve to open. So valve is open. So this is 1 and this is 1. Since both are 1, the valve is open. first one, yeah, we achieved actually, right? So now, as and when the level decreases, once it goes less than 500, this becomes off. Once become off, here we have a 1, here we have a 0. So since AND gate is like both 1 is required to become on, so this will go off. So our logic is achieved. Since the level is less than 500, we closed it. Okay, once you close it, this will become a off, then the output will become on because it's not gate. If input is off, output will be on. If input is on, output will be off. So since the output is off, the output will become on. So once it become on, you can see the AND gate here will be on, right? Also, this is the another line, the same line, like here also on. So okay, let us check this Q. So by the time when it is on, the tank level is going to be 1000 because now only you are opening. Since it is 1000, this also will be 1. And the other leg, the initial start is there. So that's why this is also 1. So now 1, 2, the 3 legs are 1. So that's then what will happen? Your second valve will open. So once your second valve is open, this tank level we are going to simulate. Once it becomes less than 500, this valve also will close. When this valve is closed, this will become off, and the output will go on. So in this AND gate, first one will be on, second one will be on, and the third one leg, if you see, as long as you did not press the whole sequence stop, it will be on. Then when both three are on, we are making a small pulse and setting it to start the agitator. So now the agitator will run. When the agitator is running, 10 seconds later, this will give a signal to the reset, it will stop. And the same signal will go to this block, set it, and then it's not an agitator, this is a pump out, the pump out. It's a pump out. Right, this is a pump out. So once the agitator is stopped, and pump out will start. So this is my initial review. See, we have not reviewed the logic is a first time implemented. Maybe you would have, like some of you right now who is watching, maybe you would have find some loophole. Something is not correct actually. Maybe possibility, because I won't say always like see, once you make it, always may not be like perfect all the time actually. Maybe some small loophole can be there, but when you do a simulation, you always can fix it if there is a problem, right? Right. So now I'm going to do the simulation test now. Let us see how exactly the whole system works. See, if you are able to understand, follow me correctly, and if this is really like you are picking up, that means like I'm sure you can pick it up any logic in the industry, right? Because this is more a slightly complex one, because pharma industries always will have some kind of some little tough logics. So this is one of the tough logic. Not tough, we could say like it's a little hard logic. Okay, it's say. So I bring this way. Right. Let's try to simulate now and see the result. Simulation. Right. So now, right, on what is this on? Something gone wrong. Some line got disconnected. Oh, I don't know why it is. So this line got disconnected for some reason. Put this. Right. All right. So leftmost is not visible. Something is coming. I don't know what it is. What is this? Some line is there. I don't know what is that line. I deleted that line. It's right. So right. Let me do a simulation now. Right. So right now, so far, when I see there is no output is on, like the valve. Let us check the valve. First valve. This is the first tank valve is off, and then this is second tank valve off. Then we have the agitator SQ03 off, and then we have the pump outlet off. All of them are off. So it looks to be okay. The system looks to be okay. So now I'm going to start this. Like, let me simulate the tank level full. Now my tank level is full. First tank is full. Second tank is full. Because basically, like you need to fill the tank. You need to fill the tank to the 1,000 liter. Maybe like still I can go offline and move it up to show you the tank level. Maybe I will disable this parameter for more clarity. Okay. Right. So now we can do a okay. Still, it has to go up offline. Still slightly will go up. Right, go for a simulation now. I just want to show you like all the value. That's why I did simulation like that. I'm going to make the analog tank, first tank 1,000. See, look at there, 1,000 you can see on the tank, 1,000 liter there. And then I'm making the second tank 1,000 liter. Okay. Both tanks are now full, because before you start the process, the operator, he has to fill the other two reactors, because without liquid he cannot start tanking. So he's supposed to fill the tank. So right now the both the tanks are full now, right? Now if you look at the Q001 is off, right? My first valve is off. Q002, my second valve is off. Agitator Q003 is off. And then we have a Q004 pump outlet is off. All of them are off. Right. Now, if I start my process, the what we expected is, we want the first valve to be open, right? Because like it has to open the first valve, and then it has to receive the liquid from the first tank, right? We are going to do now. I'm making a start. I given a start. So now what is happening, like I have given a start. So now the first valve is open, and then second valve is off, and then the agitator is off, and my pump outlet is on. Should not be on actually, because something's not correct. So I'll make it off, so I can go off. Let me something is not correct, but not perfect. Let us check. Right. This is okay. This is on. Okay. Right. Let me figure out now. So when I make it on, first valve is open, whereas the agitator also on. Should not be going on, because the here it is the very initially we are getting 1. That's what, like, see, like okay, let's check. See what is happening, like very initially this valve, first valve also closed, second valve also closed. After closing this valve, basically we are If the system is running, we are starting the agitator. That's what the logic we made actually. So that is making a little trouble actually. So it should not be there. This logic we somehow we need to make sure the logic works correctly here. So how we can fix it? Um, how we can fix it? This one is right now it is off. When this goes on here, we need to make some delay, right? So basically to achieve a logic, so right now when I start this system, it gives on here. Once it gives on here, the first wall opening is perfect. It's not a problem. But this on is also going here. Since it is a very millisecond, since both walls are closed, this logic is executing. So what you can do, you can slow down this action. Like I'll show you like how we can achieve. There's a lot of ways to achieve, but this is one of the way to achieve. Like we can put a 1 on delay timer with a 1 second. Like only 1 second we can delay the process. We can check here, we can put, and then we can connect it here. The remaining logic, whatever the logic we built, that is correct actually, but there is a small loophole that this line, since both walls are closed and once you start, then agitator is running. That's correct actually, as per the logic. When both walls are stopped and then agitator has to run. That's a procedure actually. But to avoid that, we are putting a 1 timer here, and let us simulate now. It's supposed to fix it. Right. Now we are at initial condition. Let us simulate the tank level to 1000 liter. First tank 1000 liter. Second tank 1000 liter. Right. First tank 1000 liter. Second tank 1000 liter. Now we are going to start the system. Once we start the system, we expect the Q1 going on, and when we make this simulation of 500 liter, because 500 liter gone inside the tank, then this has to go off, and then valve Q2 has to open, and then once we simulate the value 500 liter gone inside, then valve Q2 has to close. Once these two close, my agitator has to start, and 10 seconds later agitator has to stop, and then my pump outlet has to start. This is the logic, whole logic. So let us try to simulate and see whether we will be able to achieve or not. So I'm going to start now. I gave a start. Right. So I gave a start. Now if you look at my valve 1 is on. Right. My valve 2 is off. The agitator is off. My pump is off. Only the first valve is on. Nothing else. So in the process, if you see, as we discussed, we have given a start command here. When we given a start command, we want to open only this valve first, and this valve can open until this tank level is less than 500, because 1000 liter we want to pass 500 liter here. Once 500 liter is gone here, we want to stop this valve. Let us check up to this. So now I'm going to simulate this tank level. Since the valve is open, I'm sure the level will slowly drop, because the liquid from the first tank will go to the next tank. Slowly it is changing. So now if you look at here bottom, it is subtracting. What it is doing, subtracting right now 933 minus 500. It's 433. So slowly, like I'm coming to the nearby 500, like a tank level is coming up to, like I say, 529, 5. Oh, it's come down. So less than 500 it has come. You can see here now, since it is less than 500, so less than 500, the second valve open. But however, I find there was something not correct actually. The agitator take a start. Agitator took a start before I closed the second valve. So now, because what's happening, like it's a fast scanning, and that is happening. So the logic is not so perfect. So to fix it, I'll go here. The same timing, like 1 second timing, we can implement here. Okay, right. Let us do this. Right. So I'm going to do. We are slowing down. Basically, like it takes a little while to execute. That's what we are doing. Nothing else we are doing. The initial logic remains same. Only we are slowing down by timer. Let us check now. Again, simulation. Okay. Now we'll go for offline and let us stop everything and start from 0. Right. So now we are going to start the full process. I'll simulate the tank 1000 and bottom one simulate 1000. Right. I'm going to start. Look, right now Q001 is off. Q002 is off. This is a second valve. This is a first valve. This is a second valve. Maybe I can change the tag number to valve 2. Okay, I can change the it's a valve 2 or a valve 1. So valve 2. So again, I'll go for simulation and go for 1000 tank. Both tank level, I made it 1000 because 1000 liter is available. Now, valve 1 is off, valve 2 is off, agitator is off, pump outlet is off. All of them are off because I did not start the process. So once I start this process, now, yes, we need only that one valve open. The main valve, like the first reactor valve, open. Second reactor valve, off. Agitator, off. Pump, off. All of them are off. Now, the tank level slowly reduces. Now, we want to be careful, like when the valve is closed, we want to open the second tank valve, but agitator should not start, pump should not start, nothing should start. Right? That's what the checkpoint. Now, I'm going to go slowly, go down, slowly. You can see 248. So 748 tank liters there. So once it comes less than 500, like I can punch a value also directly 501. So now we have 501, like a 499 liters passed. Still the valve is open because one more liter is there. But still you could see second valve is closed, agitator is stopped, pump outlet is stopped. Okay, now I'm going to simulate 499, which is 5 liters passed. So 500 liters passed actually. Since 500 liters passed, valve is closed. You can see valve is closed. And then you can see second valve is on. And then you can see agitator is off. And pump outlet is off. Everything is perfect actually. Now, since the second valve is open, like in our, what we said, like when you push and release, we want to open this valve, and then from the tank, if it goes less than 500 liter into the reactor, you want to close this valve. After closing this valve, you want to open this valve immediately. That's what we tested. That's what checked. That's what worked so far. So once this is opened, now this liquid will start dropping because the liquid from here, it will go inside to the reactor. So let us simulate this value. We have a 1000 liter. You can see 366. That means like we pass something like a 233, 34 liter we passed inside. So if I do simulation 501. So now it's here. Sorry, 501 is here. Sorry, I by mistake I touched the top one. Okay, let me see F99. Right. So this is bottom one is here. Like this is a first input. This is a second tank. This is a first tank. This is a second tank. So second tank valve is open, and the agitator is off, and pump is out. Pump out is off. So now I'm going to simulate 501. That means now 499 liters passed into the main reactor. Still one more liter is there. You can see still the valve is open. The moment when I say less than 499, you can see the valve going off, right? Because like you need to close it. And once the valve goes closed, what we need to do, we need to start the agitator. And this agitator has to stop after 10 seconds. After 10 seconds, the pump outlet has to go on. That's what we discussed from the graphic. When I push, open the valve, fine letter gone inside, close the valve, then open the valve, fine letter gone inside, close the valve, then start the agitator, 10 seconds later open the valve, start the pump outlet. That's what we are going to see. So far we have seen first valve open, 500 liter passed, switched off. Second valve open, now waiting for 500 liter to go inside. I'm going to simulate now. I'll say 499 the same way, right? So now you can see it is gone off. First valve off, second valve off, agitator is on. Agitator is on now for 10 seconds, then it's gone off. Now the pump outlet is on. That's it. So this was the logic we were intended to do, and that's what we achieved also. See, initially when I did, it was not working. There was small correction was there. It's a normal practice. As a one stretch, you cannot do it. The logic was correct actually. When it is executing, there will be a small time delay, time seconds, some glitch will be there. So all can be fine tuned by putting a small timer, small gates and everything. You can fix the logic. So far, like the logic achieved what we supposed to be expected, I think, right? So let us execute one more time to make sure it is working, just for understanding. Right. So now let me quickly brief the logic. When I push and release the start, this valve has to open, and once the valve is open, the liquid will come down. If we simulate the level less than 500, this will close. Once it closes, this valve has to open, and this liquid we need to simulate less than 500. This will close. That means you have taken a 500 liter from here, 500 from here. So totally you have 1000 liters inside. And now we can start the agitator. Agitator will run, and then the agitator will run for 10 seconds. Like in a real life, it will be like 2 hours, 2 to 3 hours. And then once it's mixed very well, once it's reacted well, then we start the motor to take the final product to the centrifuge to take out the powder from the liquid. Right? This is the logic. So I'm going to simulate to make sure everything works correctly. I'm going to stop now. I did a stop, and I will okay, stop this. So I'll simulate the value to the 1000, simulate the value to the 1000. I have 1000 liters now. I will do a simulation again now. Right. So when I push the start, we have to open the first valve. I push start, released. First valve is open, second valve is closed, agitator is off, pump is off. So now we are trying to since the first valve is open, slowly the liquid will come down. Once the liquid comes less than 500, you can see the valve now less than 500. The valve is closed, and the second valve is open. So now the second valve is open because like the second reactor liquid need to be taken into the common reactor. So now the second tank level will go low. Once the second tank level goes low, less than 500, we should see the valve Q2 has to close, and then immediately the agitator has to go on. So you can see here, this valve is closed, agitator is running now. And after agitator is running, 10 seconds later, it has to go off, and the pump has to go on, pump is on, and every process is okay, right? So far, like whatever it worked, the way whatever like expected, it is working. Like the other one is like other one also we can test it. Like for example, like let us go for the initial stage. See, the logic, whatever you build, is supposed to be foolproof. There should be not be any loophole. Like when I start this system, right? So my first valve is open, right? And if I want to stop the whole sequence, yes, I can stop it. Like if I stop it, it should stop. So you can see here, I push to stop. The valve is closed. Valve is closed. Agitator stop. Agitator stop. So this logic we need to ensure always. Anytime when you push it stop, the logic has to stop. So I hope this logic is clear. If this logic is clear and you are able to build it by yourself, that means a real achievement, real great achievement. I'm sure you will be able to handle any of the logic requirement arises in any company, right? So I'm going to stop for 1 minute for you to ask any question if you have it, right? So the 1 minute time starts from now. Right, guys. So I start for 1 minute, and it looks like nobody has asked a question. So looks everyone is clear about the logic, and everyone understand the logic very perfectly. So I'm very happy that everybody understood the logic, right? So now, so I would say this. I will take a print screen and I will send it to you because I am not sure you may be requiring. Some print screen in future or whatever to refer. So I would have sent last all the print screen, but I forgot to make it. But still, at least I can start from now. Snip. Okay, so this one I will send it to Mauli sir. So maybe like you can get it later from him or whatever. This is a comparator and mathematics. In the pharma industries. Okay, this can be like one of the example so that it is there, and also I can send okay. So I can put you the example also so that it will be like it's a good record. So we made the I sent a sample like whatever we discussed, and I sent the coding also. So now both are available in record in somewhere. So we can pick up anytime, any day. It's required, right? So right, guys. So now we are all clear like about the mathematic calculation and the comparators, like less than, greater than. Okay, same block you can use for less than, greater than, whatever you want you can use it. So now we can make a another logic like to implement like whatever we learned so far. We will let us try to implement and then see the result, actually, right? You can develop like I will give you this example. You can build it and you try to send me the send me the logic implementation, and then let us try to run through it so that everybody can understand. So you need to attempt this one, right? Let us try this. So I will say delete all. So we will like we are not going to do anything like a complex. It will like whatever we tried. Maybe this could be a little complex, but whereas what we are trying to try is it's going to be a very simple mechanism. We will see this very simple one. The same previous examples what you made, but instead of doing the discrete, we want to do it by analog. That's what we like. With this is going to help you understand very easily. Like this is the level measurement, right? Level. Let us say we have a tank is 1,000 liters. We have in a tank we have 1,000 liter, right? And 1,000 liter meanings this the measurement is from. Okay, I'll show you where from where. Right. So this to this is a 1,000 liter. Right. So now what we want to do is like when the level goes more than 500 liter, right? So what we need to do is like it's a very simple logic. You should be able to implement, and let us see the feedback. If the level is greater than 800 liter, then start the motor. Then if the level is less than 100 liter, then stop the motor. This is the logic. See what you do. This is a combination of these two also. Like when I push the start, the motor has to start. When I push the stop, the motor has to stop. And if I don't do anything, if I increase the level more than 800, it has to start, right? And then if I reduce my level less than 100, it has to stop. But here there is a one small the requirement is this is what like a little tricky part. Like always like you make it very easy. So just to make a little complex, small one. If my level is more than 800, it can start. But when the level is more than 800, if I need to stop, if I push, it has to stop. That is the logic. So when I start the green, push and release the start button, it has to start. When I push and release the stop, it has to stop, no matter what the level is. And like for example, let us say, okay, when the level goes more than 800, it has to start. When the level goes less than 100, it has to stop. While running, if anytime I want to push a stop, I should stop. Because see, remember like when something going wrong with the motor, we should be able always to stop it. Otherwise, what will happen like since the logic is there, it's more than 800, it cannot stop. No, not the case actually. So here only you have to use the pulse timer. You have to use. Remember like the pulse timer, when the input is high, the output comes only one time. That pulse timer you have to use some combination, then you will achieve it. The goal is that while the level is more than 800, it can start. That is sure. But if I need to stop, it has to stop. Right? That's all. That is the logic requirement. So when I push and release, start. Push and release, stop. When the level goes more than 800, start. Less than 100, stop. And while running, anytime when I push, even the level is more than 800, it has to stop. Right? So you can take a time from now, maybe like now it's 11:40, maybe like 15 minutes you can take maybe up to 11:45. Sorry, 11:55, and by 11:55 we can come back, and then we will see. Let me see, like, in the meantime, how many of you sending, and if you're sending, or whoever sending, we will project and then test it. Otherwise, like, I will make it for you to make understand, right? So your time start now, from now 15 minutes. So 11:55 we will come back. You can take a picture of it so that, like, you will have it available always. So let me here. In case, if you do not understand well, something is not clear, you can always ask me so I can explain, right? So from now 1 minute for you to ask a question, and then if there is no question, yes, you can continue for 15 minutes for your logic development. By 11:55 we will come back again. Yes, guys. So, we have given you the 15 seconds, 15 minutes. So I did not get any copy from anyone. So I'm not sure. I'm not sure. Still, the almost like 26 people. Like I'm not sure whether they is present or not. But looks to be hoping that someone is there. But we'll proceed as per our training program. Right. So we'll go here and we will try to understand this. Right. What we said is when you push this start, once I push and release, the pump has to start, and then when I push and release the stop, the pump has to stop. And as we said, when the level is greater than 800, needs to start. Less than 100, it has to stop. So let us try to implement and visualize how exactly it is. Yeah, we can see it now. We'll go offline. I'll try to delete this. Yeah, as a simple start stop, like I can say this is a start, and then the other one is stop. So we have a start, we have a stop, and then we have the set reset flip flop. So we have a set, we have a reset, and then we have a motor. We have the motor is output. Right. So this is a motor. Okay, this is a normal implementation. When you start, yes, the set reset flip flop will set the output and then the motor running. Okay, correct. And then when you push a stop, again the set reset flip flop output will go set to 0, so motor stops. So this is perfect. So now we said we will take the analog value also, and the analog value, the same logic we are going to build it as how we made it. So I take the take a little space. Right. You can take a comparator. So I'll take a comparator. So I can connect this actual analog value here. Right. So I have a analog mathematic block. So I wanted to use as a this one's I think 800. So if the block needs to execute, then it needs a high. So I have given a high. So enable, this block execution is enabled now. Now it will execute, and the executed value is going to send here, which is a 500. Just I want to send a 800. So the value is greater than 800. We wanted to pass the bring the start. So here, what I want to do is here's a tricky part. I'm going to use a wiping relay, like a pulse relay, because I remember, I said, I need to be able to stop anytime, right? So what I do is I will say a pulse relay. Now, if anyone, either you start or tank level is more than 800, more than 800, your output. So if anyone comes, we want to start, either you start or the tank level is more than 800, any one comes, you want to start this. So basically what gate I use? I use a OR gate. So I take a OR gate. Right. So OR gate, this one leg is here, the leg is here. And then this OR gate goes to the start. The same way, the stop. Right? Say like a same level. You want to take the comparator, same comparator, and I connect the same analog input to this first comparator, and then the comparison value, like again, for more clarity, I will bring you inside so that I'll take out the parameter so that it will be clearly visible. Right. So now the same thing, like I wanted to copy. Here, if my value is less than 100, I want to stop it. So I am connecting this to comparator. And my comparator, okay, right now, say two gates, like either if I stop, it should stop, or if my tank level is less than 100, also should stop. Both should execute. So I mean, like anyone, either if somebody pushes the stop, or if my tank level comes less than 100, then this motor has to stop. That's it. So now this is my preliminary execution, preliminary implementation, but there can be a wrong because something is wrong, I'm sure, because in the comparator something can be wrong, but I want to simulate and test it. Right. So now basically what I want is like if my level goes more than 800, I want to start. Okay, start looks to be okay for me. That's correct. I'm trying to come for a stop. Let us see if my level is less than 100. I wanted to stop. So basically, like what I want is like I wanted to reverse it here actually, because if my level is more than 100, this is giving more than 100. It is stopping, but actually, what we want a reverse action, right? Let me do it now. So I'll make a NOT gate because I will reverse it. So I make this. Right. So now it should be all right. We will check it up now. Right, guys. So now I'm trying to simulate the level. Maybe I will keep it as middle. This is somewhere here, middle. Right. The tank has the 437 liter is the tank level. Now assume that motor is not running. Now, for some reason the tank is like slowly the tank inlet is coming. Like let me open the graphic. So assume that there is input coming. Right. So this is a water inlet. You can see. It's a water inlet. The water inlet. And this one is a pump. The address is Q001. So give a Q001. Right. So this one is the level is AI, so like a I001. It's an analog input 001. And this is maybe like it can be 2. Okay, you can say this way. This is a 1, this is a 2, and this is a 3. Sorry, 3. So this is the actual configuration. So now what is happening? Like since the tank continuously getting input, when the levels mid slowly will go up, right? Slowly will go up. Assume that slowly going up. So now tank level is slowly going up because the liquid is coming inside. But once it achieves more than 800, it has to start, right? So that's what our logic I said actually. So slowly coming up, 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 756. So now if I go more than 800, it has to start. So it's gone more than 800. So I could see the motor is running now, right? Right. So let us say the water level is coming down, coming down, coming down, coming down, coming down, coming down, slowly coming down, coming down, slowly coming down, coming down, coming down. And if it comes less than the 100, it has to stop. Then 100, no, it has to stop. It's not stopping because see, something's wrong with this pulse relay. I think I think we have taken a wrong one, actually. Wrong one. So poetry. What is this? Pulse here. I think like a wrong one we have taken. So here pulse output is here. Delete this. I will check this. Remove this. Take a 1 second. Connect it. And then connect it. Connect it back. Okay. Let us check now again. Right. So let us say the level is increasing slowly. It goes more than 800. It's supposed to start. Right. So more than 800, you can see the motor is running. Right. So now slowly the tank level is coming down, 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 down. Less than 100, it has to stop. Let us see less than 100 stopping. So now it is less than 100, it stopped. So greater than 800, it starts, and less than so now greater than 800, it starts, and less than 100, it's supposed to stop. Stop. So stop is working based on the level, right? Let us say in parallel, if I wanted to start, like for example, let us say if something level is somewhere 470, if I want to start, yes, I can start. I can stop it also. Everything possible, right? Fine. Now we said one small the glitch here is like when it is tank is more than 800, right? It's given a start, it's running, but while tank level is high, for emergency purpose, if we want to stop the motor, it has to stop. That is the special requirement. So for that only we put this pulse input, because if you don't put this pulse input, this on will come and continuously, and this continuously make it on. So now if I stop it, push and release, it stops. Though the level is high, it has given a start, but if you want to stop, it can stop, right? And again, manually, if you want to start, you can start it. Hope it should be clear, and if it is not clear, you can ask me. From now, 1 minute, I can wait for your feedback. If no feedback, then we can conclude, right? So 1 minute from now. Right. Since there is no questions, no this one like we presume all of you understand correctly, and everything is perfect. We are happy like you all understood correctly. The logic, whatever I put, maybe like I can send it to your Maurice, and then if you want, you can always get it, always available with him, right? Okay, guys, like hope we have done with this two things, like the comparator, and the comparator includes like multiple, like greater than, less than, whatever, like and then the mathematical calculations, maybe addition, subtraction, or whatever. Everything's possible with the same block. So that's what we have seen it. So we should be okay with these two. More or less, we have done with what we're supposed to do. And tomorrow, like, we will conclude with the one or two special blocks, and then we will rewind everything as a one stretch, make sure all the blocks we understand correctly, and thereby we close the training class, right? So I hope everyone understand correctly, but since you are not giving any feedback, or since you are not interacting, I am not sure. First of all, you are there or not, that's the one question. Other one is whether you understand or not, the second thing. And so too many questions are there, but so far it's not clear to me that nothing is clear. But anyway, I presume, so only I can presume that you understand correctly, right? Right, guys? Then we can see by tomorrow 9 a.m. Right? Okay, guys, take care. Bye.